So let's look at some characteristics of our quadratic functions. So this form that we see at the top here, this is our standard form, where we have our ax squared plus bx plus c. So the key to recognizing that it's quadratic is that we have this term with x squared. So when we have a quadratic, a cannot equal 0. B could, c could, so those might not always be there, but you definitely need this x squared term to make it quadratic. Now the general form of a quadratic function, it draws a parabola, and there's essentially two ways these parabolas will show up. There's going to be where it opens up, which is going to be called concave up, and we'll talk about concavity more later on. And then there's also concave down, which is where it opens downward. Now the direction of the parabola depends on A and whether it's positive or negative. If A is positive, then we're going to see this opening up. If it's negative, then it opens downward. Another piece of information that we get from the standard form is the Y-intercept. The Y-intercept comes through as the value for C. So to find a Y-intercept, we're plugging in 0 for x, and then we're looking for what f of 0 is. Well, in this form, if we plug in 0 for x, then those first two terms are just going to cancel out, and all we'll be left with is our constant. So another way in the standard form is for the Y-intercept is always going to be 0, and then whatever c is. All right, let's look at some of the pieces we can calculate with this standard form. So, first piece here, find the Y-intercept. So, with our function up above here, so you can either go about plugging in 0, that's our general way of finding our Y-intercept, is let x equal 0, and then we could solve. So let's look at that plugged in here. So if I wanted to find f of 0, we would have negative 4 times 0 squared minus 2 times 0 plus 42. But as you'd see, after all that solving that we would do there, we would just be left with that 42. So in the standard form, we just have c. So with that, we're going to see we have this Y-intercept where x is 0 and y is 42. So with that, we get a coordinate to draw. The vertex. So we have a formula for the vertex. If we're in the standard form, the x-coordinate is going to come from taking negative b over 2 times a. So that'll calculate our x-coordinate. And then to find the y-coordinate, we just plug in x into our function. So let's try this out. So if we go to our function and just grab a, b, and c, so a is negative 4, b is negative 2, and c is positive 42. So if I want my x-coordinate, I'm going to take negative b, so I'm going to have negative, and b is a negative 2, so I'm going to end up with a double negative there. One negative coming from the structure of negative b over 2a, and one negative coming from the actual number, all over 2 times a, which a is a negative 4. And then we're just going to simplify this down. So a double negative makes a positive, so we'll have positive 2 over 2 times negative 4, which is negative 8, which will simplify that down to a negative 1/4. Now what we're going to do is to find the y value, we're going to look at f of negative 1/4. Now here, I'm going to use a calculator to help me out. So let's see how this plugs in to a calculator. So we have our scientific calculator, and just wherever I see x in my function, I'm going to plug in negative 1/4. So negative 4 times negative 1/4, and that's going to be squared, and then minus 2 times negative 1/4. Oops. Not an equal sign there. Let me edit that. All right. I'll just close that parenthesis, and then plus 42. And we get a 42.25. So if you have a messy x-coordinate, or you're like me and just want to avoid fractions as much as possible, use a calculator to help out. And this form is great. If you wanted the fraction form, you could have the converted fraction there. Let's go ahead and use the decimal form. So, because that'll be easier to graph when we get there. So where I have -1/4, I'm going to think of that more as -0.25, and I could have plugged it into the calculator that way. And then this was a 42.25. So with this, I get a coordinate, and it's the vertex of the function. And the vertex, as a refresher with a parabola, is if it's concave up, if it opens upward, then it's the minimum point. If it's opening downward, then it's the maximum point. So that would be our vertex, which will just be a coordinate on our parabola that comes through as the maximum or minimum. So with that, we have this coordinate of -0.25, positive 42.25. All right, the factored form of f of x. So what I'm going to take is our function, f of x equals -4x squared minus 2x plus 42. And I'm going to factor. So I have a greatest common factor here. I'm going to factor out a -2. So that'll leave me with positive 2x squared, positive x, and a -21. Now you can use the trial and error method. If you have other methods you've been using for factoring, use those. Oh, just for some practice of the AC method, I'm going to show that here. So AC is where we take our value A times C. So with our 2 factored out there, my A value is now 2 times C, which is a -21. So I'm looking at factors of -42. And I want the factors to add up to a +7. So what I start doing is thinking about factors that are just one away from each other. And with 42, that's going to come through as a -6 and +7. So with that, what we would do is split up our middle term using those factors. So my function is going to be -2 and then 2x squared minus 6x plus 7x minus 21. And then I'm going to do some factoring by grouping. And let's see, on the left-hand side, my greatest common factor is 2x, which will leave me with an x minus 3. And then on the right-hand side, greatest common factor, +7, and factoring that out will leave me with an x minus 3. All right, one more step and then we're at our factored form. So -2 keeps hanging out on the outside there. We have this common factor of x minus 3. And then our leftovers will be the 2x and that +7. All right, we have our factored form. So now we want to know what are the x-intercepts. So the x-intercepts occur when f of x is equal to 0. So when we set our function equal to 0, which we could have done in this non-factored form. I could have plugged in 0 for f of x up here, but then we go through that process of factoring in order to solve our quadratic equation. So this just kind of gave us a head start with that, because to do this, it makes it a lot easier to have your function in factored form. So let's see how this works out. What I'm going to do is plug in 0 for f of x. So I'm going to have 0 equals -2 times x minus 3 times 2x plus 7. And with that, I can start setting my factors equal to 0. So the -2 doesn't have x, so we can ignore that one. But we have that x minus 3 should equal 0, or 2x plus 7 should equal 0. And then we'll solve them. So add 3 to both sides to get x equals 3. We're going to subtract 7 from both sides to get 2x equals -7, then divide by 2. and these are going to be our X-intercepts. So this is where we cross the X-axis. We have two coordinates. We'll have a 3, 0, and a -7/2, 0. Or for graphing, I'm going to go ahead and put that in decimal form to make it easier to place on that number line. So if we find these pieces for our quadratic function, we have a lot of points that we can draw and can get a pretty good sketch going for our parabola. So we have our Y-intercept, which comes from plugging in x = 0. We have the vertex, which comes through using this formula right here. And we have our X-intercepts, which requires finding that factored form first, setting it equal to 0, and then solving for x. So let's go ahead and plot these points. Now setting a scale, for the x-axis I need to graph a 0, a -1/4, and 3 and -3.5. So I'm thinking a scale of 1 is pretty good for that. So in fact, I'm going to do that 2 blocks equals 1. So really I'm doing steps of a half. So 1, 2, 3, 4, -1, -2, -3, -4. Alright. Then for my y-axis, I need 0, which we'll have with the origin. I need to see all the way up to 42 and 42.25. So that I need to stretch my y-axis quite a bit. So how about we do jumps of 5? So I'm going to go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And then we're going to plot our points. So for the y-intercept, we're at 0, 42. So I'm just going to estimate that best I can right there. For the vertex, we're at -1/4. So I'm about right there on the x-axis. And then I'm just a little bit higher than 42. So this is going to be real close, but something like that. And if you want, you could use symmetry about the vertex. This vertex is going to be halfway, right in the middle of our parabola. So you could get another point out right here and say we'll have something that's about right there where we have symmetry about that vertex. We didn't find that coordinate, so I won't graph it, but it is there. So as you graph these quadratic functions, if you get used to seeing that symmetry there, you can absolutely use that. Alright, and then our two other points are the x-intercepts, so we have +3 and -3.5. Alright, so with this, we are going to now connect the dots. So, something like this. Let me try that one more time. That didn't come out very nice. This is when it's nice to use a pencil. There we go. Alright, that's our parabola. So, make sure you set the scales accordingly on your axes so that it can fit. And then we can see our x-intercepts, y-intercept, and the vertex coming through. Now this last question here is about the axis of symmetry, and that's what I was talking about with the vertex, is that there's this axis right here that goes through the vertex that is like this mirror that's occurring. Everything that's happening on this right-hand side is symmetric with what's happening on this, and I just switched my right and left. What's happening on this left-hand side is the same as what's happening on the right-hand side. So with that, we have this reflection going on and symmetry. So this axis of symmetry is a vertical line. So with that, we use x equals to describe it. So your axis of symmetry will always be x equals some number. And the number that you use is the x-coordinate from the vertex. So for us, this would have an axis of symmetry of x equals -0.25 or -1/4. So that's working with the quadratic function in standard form.